Okay, students. Okay, sir. This is the Good morning. This is the Suraj Patil. Yeah. This is the continuation class for the chapter 2, relation of function. Okay, sir. In previous class, we have discussed about some different functions. Okay, sir. Constant functions, exponential functions, logarithm functions. Okay, sir. Identity function, polynomial function, and greatest integer function, and last one is fractional part function. Various. Okay, sir. So on base of that functions, okay, so we will solve some various examples today. Okay, so just basic one example is first one is the greatest integer function or integral function, integral part function. Greatest integer function. F of x is equal to x. Okay, sir. And this x is less than greatest integer power function means okay, sir. This is the mod of x is less than or equal to x always. Okay. For this you can tell okay, x belongs to any r. One one wonderful formula is there that is very helpful solving the question. Okay, sir. If f of x is equal to k, okay, sir, and k belongs to any integer, positive or negative integer, then okay, sir, k is less than or equal to x and less than k. Okay, sir. This formula okay, sir, oftenly used while solving the questions. Okay, first one is solve the following. First one is okay, so greatest integer of 3 minus 4 is equal to 5. Okay, sir. The greatest integer part of the 3x minus 4 is equal to 5. Then what is the value of x? Okay, sir. See, I am telling that this is the wonderful formula for this example, especially for this function. Okay, the greatest integer function or integral part function or step function. This name is there. Okay. Just apply the system. Okay, if 3x minus 4 is equal to 5, then automatically 5 is less than or equal to 3x minus 4 is less than 5 plus 1. This is the k plus 1. Next function, next number. Just start the simplification. This becomes okay. If you are getting confused, you can sir, bifurcate it into two parts. Okay, this is 5 less than 3x minus 4. Another one is 3x minus 4 is less than 5 plus 1. This becomes 9 by 3 less than or equal to x. Okay, this becomes 6 plus 4, 10. X is equal to x is less than 10 by 3. Okay, the function from less than 9 by 3 plus x equal to 9 by means is right now x is greater than 3 and x is less than 10 by 3. Okay, if they are given, what we should write? Okay, x is greater than 3 by 2 is equal to, we can write greater than 3 by 2, 3 and less than 10 by 3. Okay, the open bracket and close bracket, equal symbol. Yes. Okay, sir. This formula, okay, if f is a greatest integer function or integral part function or step function, okay, sir, three names are there. Okay, sir, integral part function or step function. Okay, then okay, sir, if k and k is the integer value, then this is the condition. Almost because You can write this one only. Which one? Okay, sir. Okay. Mod of x is equal to less than or equal to x. So this value should be less than or k less than, okay, sir, k only. K or k plus 1 only. Next question is okay, sir. Next question is 1 minus 2x is equal to minus 3. Okay, sir. What is the greatest integer value for this function? Okay, sir. Same again. This is the formula. If x is equal to k, then k belongs to integer number. K is less than equal to x and x is less than k plus 1. Okay, the same method. Solution. Okay, sir. What is the solution for this? Same right as it is. Okay. 1 minus 2x is equal to minus 3. If I am writing, okay, this is the x, this is the k, minus 3, okay, sir, less than or equal to this value 1 minus 2x less than minus 3 plus 1. Okay, sir, k plus 1. Okay, this becomes minus 3 less than or equal to 1 minus 2x. Okay, sir, becomes minus 2. Okay, so sir, last time I, okay, sir, separated the two inequalities. Okay, instead of wasting time, okay, making separately, just write for that only. Okay, this becomes, okay, sir, minus 3 minus 1, this becomes this side is less than minus 2x. Okay, sir. And okay, same, bring this line, okay, sir. Okay, then 2x is equal to, okay, sir, 1 becomes right side less than minus 2 less than minus 2 less, okay, minus 1. Okay, this becomes minus 4 is less than minus 2x, which is less than minus 3. Okay. This becomes, okay, so all our right side there, okay, sir, multiply by the positive or just rearrange the terms. Okay, this becomes, okay, sir, this becomes 2 is less than x is less than 3. You can write 2 is less than x less than 3. Yes, sir. Because now the right side you can remove the result by multiplication. Okay, sir. Then x belongs to immediately. Okay, sir. 2 is less than 3. 2 and okay, less than 3. This becomes, okay, 3, 2, okay, this becomes 3 and 2, close bracket, is it? Yes. Close bracket. If you are getting confused, okay, 2 is less than equal to x means x is greater than or equal to 2 and x is less than 3 means you can write directly. Okay. X is greater than or equal to 2. This is the lesser value. This is the greater value. Lesser value and greater value. Yeah. Third one is, okay, sir, there are simple questions only, but they are quite, okay, sir, critical questions, okay, very important questions. This will give you a huge importance in your solving, because long exams are in competitive exam fields. Next, given 3 is, okay, sir. Next question is, okay, quadratic question. Okay, so it is a function of square and multiplication of 5 plus 6 is equal to 0. So what is the possible values of x? Simple solution. Okay, sir. Just consider the simple simple terms of x. Okay, sir. X minus 5x plus 6 is equal to 0, and this becomes, okay, sir, x square minus 3x minus 2x plus 6 is equal to 0. X into, okay, sir, x minus 3 minus 2 into x minus 3 is equal to, okay, sir, x minus 2 and x minus 3 is equal to 0. Simple. Simply, sir, same like this one, okay, sir. Mod of x, okay, sir, integer function of x minus 2, okay, this one into integer function of mod is equal to 0. So what, anyone becomes 0, no? So this becomes 2r, and this becomes also 3. Okay, sir. This becomes 3 and this becomes 2. What is the formula again? Okay, sir. This is s is less than or equal to x less than or equal to 3. For this, okay, sir, 3 is less than or equal to x less than 4. Okay. Our value what is x is less than 4 and, okay, sir, greater than 2. Okay, 2 is less than 2, x 2 is less than x means x is greater than 2. 2 is less than x. Okay, sir, here if 2 is less than x means x is greater than or equal to 2, and here x is less than means less than 4 means you can write now x as means 3 to 1 0. Okay, sir. Therefore x belongs to, okay, sir, 4 to 2 closed interval. Is it? Okay, 2 to 4. I have taken reverse. Okay. So here is, we have to consider 3 also. Okay, sir. Have to consider 3 also. So what is the answer, sir? This becomes, see, there are 2 inequalities. 2 is less than or equal to x and 3 is less than or equal to x. Again, x is less than 3 and x is less than 4. Yes, for, see, here, you should get this value also, you should get this value also. Okay, sir. 2 is less than x means x is greater than or equal to 2. For this you can write 2 something. For x is less than 4. 4 means we can write 4. Okay, therefore x is belongs to, okay, sir, this is the lowest function. There is a sense we need 3 also. Up to 2, 3, 4 is not considered. Okay, sir. This is the 2 and 4 in open bracket. Yeah. Next example is next question is, if f is a function from R to R and f of x is equal to 2 to the power x. Okay. Then they ask find the range and find this one. F of x is equal to 1 and prove the f of x plus y is equal to f of x into f of x. Okay, sir. This is the exponential function. Yeah. Exponential function with base 2. Okay, sir. First take the domain y is equal to 2 to the power x. Okay, sir. Okay, sir. See here liberal to take any values of x. Okay, sir. Means here right side you can take any values of x. If take x belongs to R, means domain of f is equal to R, you can take any values. Let us see, sir. For x equal to 0, y becomes 2 to the power 0 means 1. Okay, sir. If x equal to less than 0, Okay, sir. So y becomes 2 to the power, okay, sir. Less than 0 means, okay, sir, 1 by 10, 1 by 2, or minus 1 minus 2, like that. Okay, okay, sir. 2 to the power 1 by 2. This becomes, okay, sir, square root of 2, because greater than 0. Still you get positive value. And y, okay, sir, if x equal to 2 to the power minus x, this becomes, okay, sir, minus 1 becomes minus 1, minus 1, 1 become 2, again greater than 0. Okay. Take y is equal to 2 to the power minus 2 becomes 1 by 4, again greater than 0. Therefore, okay, range is, okay, sir, domain is R, but the range of f is equal to almost 0 to infinity. Yes, sir. Range is 0 to infinity, is it? Yes, sir. So here, why I am not writing this? You will get the value of lesser than, okay, sir. Here, you will get the value of lesser than 1. See, 1 by 10. Okay, sir. 2 to the power 1 by 100. Okay, so you will get again get a value is just greater than 0. That's why value is not defined in 0. Still, you will get the which one? Some lesser values. Okay, sir. At 0 is equal to 1. Okay, this function becomes, that's why. Okay, if it depends on the way, okay, sir. A is greater than 1, and this becomes, okay, sir. This becomes like this. Okay, for any values of x, values of y decreases. Okay, okay, sir. This is the at x equal to 0 constant. Okay, sir. For this one, neither you will get greater values of y, which becomes a is less than 1. Let it be. Range is 0 to infinity and domain is R. Okay, sir. Therefore, for exponential function, domain of f is equal to R and range of f is equal to 0 to infinity. And next question is, okay, sir. Next question is, find the x, okay, sir, value of x such that f of x is equal to 0. Find the second one is, okay, f of x is equal to 1. Then find the value of x. Okay, sir. F of x is equal to 1 means just put the value as 2 is equal to 0. Okay, so f of x means 1. Put the value of x in this equation. Okay, so 1 becomes 0. So here, sir, you can write 2 to the power 0 is equal to 2 to the power x, because any function to the power 0 gives values 1 only. Mathematical identity. So, okay, sir. Therefore, the base is same, then their corresponding exponentials will be same. Because therefore, x is equal to 0. Value is it? Yes. Then again prove that f of x plus y is equal to f of x into f of xy, f of x into f of y. Third one, prove that f of x plus y is equal to f of x, f of y. Okay, that proof. See, solution. What they given? F of x is equal to, okay, sir, f of x is equal to 2 to the power x. Then f of x plus y, any value, this becomes 2 to the power x plus y. Okay, sir. This becomes 2 to the power x, 2 to the power y, because any value a to the power x plus y, or you can tell also a to the power x into a to the power y is equal to a to the power x plus y formula. Okay, sir. This because you can write f of x into f of y. There are two variables. Therefore, for the exponential function f of x plus y is equal to f of x into f of y. Hence proved. Again, next question is okay. Next question is the function from r plus to r and f of x equal to log of x to the base e. It's called logarithmic function. Okay, sir. Logarithmic function. Okay. Logarithmic function. Okay. Here, domain is positive. It's a positive real number. Positive real number. Okay. And range is r itself. First question on they ask what is the range of f? Okay, sir. Range of f. Okay, sir. Here, domain of f is equal to r plus, and range is almost, okay, sir, is equal to belongs to almost r only. Okay, sir. We can take the for any values of x, we can give the here. This is y is equal to log of x to the base e, and this becomes x is equal to e to the power y. Okay, sir. This okay, sir, e to the power y is always greater than 0. Yes, sir. Always greater than 0. Here, this is the domain. Okay, this is the domain. Okay, this is the domain. You can write log of x is equal to this is equal to y function. This is the any function. If you have taken f of x is equal to which one? Anyone. Okay, sir. 2x x plus 3. Okay, sir. This part means this part becomes domain, and this becomes range. Similarly, okay, sir. This log part becomes domain, means this, okay, sir, e to the power y becomes domain here. So always that size is almost greater than 0, and x you can take any corresponding values. Therefore, range is almost, okay, sir. Okay, range becomes, okay, the range becomes almost all any, okay, the range of f r f is equal to belongs to r, any real number set. Next, find the x such that f of x is equal to minus 1. Okay, sir. F of x is equal to minus 1. Okay, sir. Okay. F of x is equal to minus 1. Question number 2. F of x is equal to minus 1 means what is f of x is equal to? Log of x to the base e is equal to minus 1. What is the formula, sir? X is equal to a to the power y. Say right, I am writing this is equal to e to the power minus 1. X becomes 1 by e. X is equal to 1 by e. Yes. Further prove that, also prove that f of x is equal to f of x plus f of y. Third one is also prove f of x into y is equal to f of x plus f of y. Yes. What they given? Yes, sir. F of x you can write log of x into y to the base e. So this automatically becomes, okay, sir, log of to the base e x plus log of to the base e y. Directly by the formula. Directly by the formula. Yes, sir. Okay, sir. Some introduction, okay, sir. Basic idea about the exponential function and logarithmic function. Okay, sir. Let's give you some examples. Both have different domains and different ranges. Okay. See, for exponential function is called y is equal to, okay, sir, y is equal to a to the power x. Okay, this is called exponential function. Okay, sir. Exponential function here for all values of x. Okay, sir. Whatever take the values of x. Okay. Okay, sir. If x is equal to 0, then y becomes 1. If x equal to, okay, sir, x is greater than 1, okay, depends on the y also. Okay. For condition a is greater than 1, okay, sir, and x equal to greater than 1, y becomes again positive. Okay, sir. Means okay, 2 to the power 2, you can write, is equal to positive value. Okay, sir. Similarly, if a is, okay, sir, here condition x is less than 1, y becomes, okay, sir, what becomes, okay, 2, 1 by 1 by 2, 1 by 2 to 4, 1 by 2 to 4, whatever may be, this becomes again positive range. Okay, sir, for a is less than 1, okay, sir, a is less than 1, okay, sir, x is greater than 1, y becomes, okay, sir, 1 by 2 to the power 4, again positive 4, with whatever values, okay, sir. If x is less than 1, okay, sir, listen up carefully, x is less than 1, okay, sir, y is equal to, okay, 1 over 2 to the minus 2, this becomes, okay, sir, this becomes 2 to the power 2, this becomes 4, again 4, okay, sir. Means for exponential function, okay, sir, range is positive, range is belongs to 0 to infinity, and domain you can take, sir, x equal to 0, x equal to 1, x equal to less than equal to, so okay, domain becomes, okay, sir, R for exponential function. For logarithmic function, okay, for logarithmic function, let's take, okay, sir, x is equal to a to the power y. Okay, sir. Here it's also called, okay, sir, log of x to the base a is equal to y, or y is equal to log of x to the base a. Okay, sir, this gives some complex picture in our mind. Okay, so complex picture, but not possible to understand what the values are goes or down. Okay, sir. So take this one. Okay, take this one. X is equal to a to the power y. Okay, sir. Here, see, x is, I can't take the values liberally because I take the calculus. Okay, sir. If taken 2 is equal to 2 to the y becomes 1. Okay, sir. If I want to take 1, 2, 3, 4, 5, here highly possible to take the, okay, sir, values of 2 to the power or something else. Okay, but still x exists something. Okay, what I am taking right now, okay, sir, I am taking the values of y. Okay, sir. If, okay, sir, if a is equal to greater than 1, okay, sir, then y equal to 0, okay, sir, x becomes 1. Okay, sir, x becomes 1. Okay, and y is greater than 1, okay, sir, again x becomes positive. If y is less than 1, okay, sir, again less than 1 means, okay, sir, you can write na, less than 1 means x is equal to, you can write, okay, sir, a to the power minus 2, this becomes 1 by a square, again positive value because y is positive. Okay, sir. For a is less than 1, okay, sir, less than value, negative values or less than 0, you can take, okay, sir, so x becomes a to the power, okay, sir, almost becomes 1 by a y. Okay, sir. this values, whatever values, becomes already greater than 0. Okay, sir. Therefore, here domain is positive. Okay, sir. Here domain belongs to 0 to infinity, and range y, you can take any values of y, belongs to R. Okay, sir. Therefore, exponential and logarithm functions almost all they are opposite in nature. They are inversal, reciprocal in nature, universal, sir. Inverse in nature. Inverse function, both are. Okay, sir. Example, next example is okay, sir. Next question is f of x is equal to okay, sir, log of 1 plus x divided by 1 minus x, and prove that pt f of 2x by 1 plus x square is equal to 2 into f of x. Prove that. Okay, sir. These are x's only. Okay. And these are 2x only. 2x x square. Okay, sir. Prove that f of 2x is equal to 12 of x. Okay, sir. Solution is okay, sir. Just put the simple condition. Okay, sir. F of x is equal to okay, sir, log of okay 1 plus x over 1 minus x. Okay, sir. Same condition. So if then f of 2x divided by 1 plus x square becomes okay, sir, log of similar values, same as it is. Okay, sir. 1 plus 2x divided by 1 plus x square divided by 1 minus 2x divided by 1 minus x square. Okay, sir. Next, just simplify it. Okay, sir. This becomes log of okay, sir, this simplification. Okay, sir. 1 plus x square plus 2x divided by okay, 1 minus x square minus 2x. This is 1 plus x square. Okay, and this 1 by x square and 1 by x square get cancelled. You can write also 1 plus x square 1 plus x square. Okay, sir. This get cancelled. Remaining is log of okay, sir. Okay, sir. Then this you can write x plus 1 whole square. Okay, sir. This you can write x plus 1 whole square, and this you can write x minus 1 whole square. Okay, sir. This you can write okay, sir, x plus 1 divided by x minus 1 whole square. Okay, sir. This becomes okay, sir. This becomes 2 into log of okay, sir, 1 plus x divided by 1 minus x. Something is changed. Okay, here they given okay, see this is a okay, square number na, so this you can write okay, sir, here 1 minus x whole square, because okay, sir, x minus 1 whole square is equal to x square minus 2x plus 1, and 1 minus x whole square is equal to 1 minus okay, sir, 1 minus 2x plus x square. Okay, sir. That's all. 1 minus x. Okay, sir. Becomes what is the value is? This is equal to 2 into f of x. F of x. Answer. Hence, f of 2x by 1 plus x square is equal to 2 into log 2 into 2 times of f of x. The next question is yes, sir. This I think so. There are some remaining questions are easy.
other case. This is the quite okay, last question is quite important question. F of x is equal to 1 over the root of, okay sir, let us change the function square and minus this integral function minus 6 is equal to find the domain. Okay, they ask to find the domain of f. Okay sir, whatever it may be. Okay sir, here in I am telling sir 1 over 0 is 0. Okay sir, is not defined at all, because sir 1 you cannot write 0 into some multiples of any elements p. Okay sir, it does not become, that's why this function whatever it may be should not become 0. Okay sir, this should be greater than 0 always. Okay sir, therefore are taking for this belongs to function real numbers, and this portion, okay sir, the square root function must be greater than 0. Okay sir, that I am writing this square root function x square minus x minus 6 greater than 0, not equal to, must be greater than 0. 1, 2, 3, 4 something else. Okay. Okay sir, this is in the form of x square minus x minus 6 equal to 0, and this becomes, you can write sir, x square minus 3x minus 2x. You can write what are the fractions sir? These two functions sir. Okay, the plus is there, no? And plus 2x, and this becomes minus greater than 0. And this one, x is common, x minus 3, and plus 2 is common, x minus 3 greater than 0. So x plus 2 and x minus 3 greater than 0. Okay, our solution is mod of, okay sir, greater function plus 2 and greatest integer function minus 3 greater than 0. Okay sir, for this condition we have the formula if x, okay sir, then if x minus a into x minus b greater than 0, okay sir, greater than 0, what is the formula? Okay sir, x is less than a or x is greater than b. For this condition, x is, okay sir, less than a or x is greater than b. Okay sir, once I have they given the formulas in here. Yes, x is less than a and x is greater than b. Okay sir, apply for this formula. Okay, this becomes, okay sir, here mod of x becomes, okay sir, greater than minus 2. Okay, for this first purpose, okay sir. So this I can write c x minus of minus 2, and this becomes x minus 3 greater than 0. Okay sir, after this condition, then x becomes less than minus 2 and x becomes here greater than plus 3. Okay sir, it goes right side. Okay sir, domain, they ask the condition. Okay sir, and this x is less than minus 2 means, okay sir, x belongs to this one minus 1 0 1 x greater than 3. Okay sir, this goes again, and x belongs to greater than 3 means 4 5. Okay sir, like this only. Okay, okay sir, 4 one 4 is included. Okay, greater than 3. Okay, greater than 3 means you can write this 3. Okay sir, and this function becomes, okay sir, this function becomes, okay sir, you can write minus 1. Okay sir, this is less than only, so I am taking minus 1 to infinity, Okay, x value is less than minus 2, less than minus 2 is minus 2 here. Okay sir, less than minus 2 means minus 4. Okay sir, this is sorry, minus 3, minus 4 up to minus infinity. Okay sir, then this becomes which one? Minus 2 to, okay sir, minus 2 in reverse order. Yeah, just a bit confusion. X belongs to, okay sir, this belongs to minus infinity, okay sir, minus infinity to minus 2, and this becomes, okay sir, 3 to infinity. Okay sir, combining the both values we will get, combining the both values, see here you can get x belongs to union of, okay sir, and this is the, this one, this belongs to minus infinity to minus 2 union of, okay sir, 3 to 8, okay sir, infinity, or you can write sir, the given 4 is the closed, okay sir, closed bracket. How means, okay sir, implies, okay sir, minus infinity to minus 2, okay sir. Here you can write minus 2 also, then, okay sir, minus 3, okay sir, union of, okay sir, 3 is not included, so next 4 must be included, okay, 4 to infinity, okay sir. Minus 2 is not included, so minus 3 will be, okay, minus 2 is not included means minus 3 will be included, okay sir. So here this is also correct and this is also correct, okay sir. Then book they given this as the closed bracket for input, okay. Okay sir, this is the some basic examples for the which one, real functions or special real functions. Already the previous class I discussed the what are the functions, real functions. In this class I am decided to discuss about the some examples, okay sir. This gives some, okay sir, glimpses of the questions, okay sir. They are the fundamental. If and then they will ask the greatest integer function, logarithm function, exponential function, and okay sir, the derivative function. So it makes the twist to the our answer, or twist to the our solution, or twist to the our derivation mechanism, okay sir. To having the basic knowledge about these some very important functions, sir. Especially these 6-7 functions are there now, fundamental, okay sir. Very important for our exam purpose, okay. And this is the conclusion. And next class we will come up with some algebra of functions, okay sir. Operation of real numbers, okay sir. Next class we will discuss about the operation of real numbers, means plus, minus, negative, something else, okay sir. And then there would be that would be our final class for the, okay sir, for the chapter second, relation and function, okay sir. Thank you for watching.